Hello everybody and welcome to today's lesson on solving logarithmic and exponential equations. Today our objectives are we will solve equations involving exponentials and logarithms, and we will apply the properties of exponentials and logarithms to real-world scenarios. So how do we solve exponential equations? There are two methods that I want to show you today. And in the first method, our goal is to make both bases be the same. And if that's the case, then we can just take their exponents and set them equal to each other and solve that equation. So in our first example here, we got 3 to the power of 5x minus 6 is equal to 9 to the power of x. Now 3 to the power of 5x minus 6, and the 9 we know is 3 squared. And that way we now have two bases that are the same. So now we just need to distribute those exponents on the right, and we have 3 to the power of 5x minus 6 is equal to 3 to the power of 2x. Remember, when we raise a power to another power, we multiply the exponents. And now we have two bases that are the same. Both have base 3, so we can now just take the exponential expressions, 5x minus 6, and set that equal to 2x. And now we're going to solve for x. Subtract 2x from both sides, we get 3x minus 6 is equal to 0. Add 6, 3x is equal to 6. Divide by 3, and x is equal to 2. In our next example, we got the bases 4 and 1/2, and we know that both of those are actually powers of 2. So we just need to find the power of 2 and substitute that for 4. 4 is 2 to the power of 2, and 1/2 is 2 to the power of negative 1. All that negative 1 exponent does is flip the numerator into the denominator. So then we distribute our exponent, we get 2 to the power of 2x is equal to 2. Now here we also have to distribute the negative 1 to both of those terms to get negative x plus 3. And we have two bases that are the same. Then let's go and just set the exponential expressions equal to each other and solve by adding x to both sides. 3x is equal to 3, dividing by 3, and x is equal to 1. So this first method is all about making both bases the same. If we can do it, we should definitely try to do that. If that's not possible, then use method 2, and here we are going to take the logarithm of both sides of the equation. And it doesn't really matter which logarithm you take, because you're going to get the same answer in the end. And if you are using your calculator, which you will do most likely for the last step anyway, then that'll do the work for you. But sometimes you can pick a base which will help you to eliminate some stuff, and that'll make things easier. So here we have 4 to the power of x is equal to 11. 4 is the base of our exponential expression. So I'm going to take a log with base 4 of 4 to the power of x. And I'm going to take the log base 4 of 11. So now I got my exponent here that I can move to the front, and I get x times the log base 4 of 4 is equal to the log base 4 of 11. And here now let's look at this expression, the log base 4 of 4. What exponent will turn 4 into 4? And the answer is 1. So this is nothing else than 1. X times 1 is just x. So x is equal to log base 4 of 11. And as you put that into your calculators, you will get the answer. X is approximately 1.73. In our next example, I got 7 to the power of 9x is equal to 15. And since now 7 is my base, I'm going to take the log base 7 of 7 to the power of 9x and the log base 7 of 15. Now our 9x in the exponent we can move forward as a coefficient. We get 9x log base 7 of 7 is equal to log base 7 of 15. And just like in the example before, log base 7 of 7 is 1. So we got 9x times 1, and that is equal to log base 7 of 15. If we want to know what x is, we just divide both sides by 9, and x is equal to log base 7 of 15 divided by 9, and that is approximately 0.155. In our next example, we have to first do some steps before we have our exponential expression isolated. So let's add 7 to both sides. 4 times e to the power of negative 0.3x is equal to 20. Divide both sides by 4, and e to the power of negative 0.3x is equal to 5. And now we're going to take a logarithm again of both sides. And since we have our e right here as the base, I'm going to take the natural logarithm of e to the power of negative 0.3x and the natural logarithm of 5. Move my exponent into the front, and the natural logarithm of e is also 1, so negative 0.3x is equal to ln of 5. Divide both sides by negative 0.03, and x is equal to ln 5 divided by negative 0.03, and that is approximately negative 5.365. In our next example, we have to do a few more steps, but let's just start off again by taking a log, and I'm just going to pick ln, the natural log here, of 3 to the power of 2x plus 1, and the natural log of 2 to the power of x plus 2. Now we move our exponent to the front. 2x plus 1 times ln 3 is equal to x plus 2 times ln 2. Now we're going to eliminate our parentheses by distributing our logs, and we get 2x ln 3 plus 1 ln 3 is equal to x ln 2 plus 2 ln 2. And in our next step, we're going to move all the terms that have an x to the left and all the terms that do not to the right. So 2x ln 3 minus x ln 2 is equal to 2 ln 2 minus ln 3. In our next step, we're going to factor out our x. So x times 2 ln 3 minus ln 2 is equal to 2 ln 2 minus ln 3. And now divide everything by this expression. That's a big one. 2 ln 3 minus ln 2. 2 ln 3 minus ln 2. On the left, this cancels out and we are left with just x. And this we're going to do on our calculator. So now be careful. Open parentheses. 2 ln 2 minus ln 3 close parentheses again divided by open parentheses 2 ln 3 minus ln 2 close parentheses twice again, and the answer is x is approximately 0.191. Alright, so much for now, and now go ahead and watch the second part of this tutorial.